Hello, Pre-Calc Honors kids. Today we are going to start a unit on vectors, and we're going to go through the basics on vectors. Some of you may have had that in physics, some of you may not have, but it should be pretty general. I'm here today with my dog Izzy. She's been my teacher aide for 11 straight years. So if you hear awkward snoring in the background, it is coming from my half pug, half Boston Terrier dog named Izzy. You can follow these notes along in your OneNote if you like. I have sent them out into your Chapter 6 notebook. So I will pause for a moment so you can open that up. Okay, there is a difference between velocity and speed. Speed only has magnitude, where velocity is both magnitude and direction. I'm going to pause for a moment and allow you to read through the next few definitions. Okay, vectors can be represented in the component form, as you see here, the vector u, which is in the component form of AB, which specifies the horizontal and vertical components of a vector, or a directed line segment like the vector u or the vector AB. Vector in a Cartesian rectangular coordinate system. So below I have a vector u. I have placed it at the origin, and it's drawn in standard position. The length of the directed line segment representing the vector is the magnitude of the vector. And we can use Pythagorean to help us find the magnitude, as you can see by the formula below. Two vectors have the same direction if they are parallel and point in the same direction. Two vectors have opposite direction if they are parallel and point in opposite directions. We can claim that vectors are equal if they have the same magnitude and the same direction. I'm going to go through example 1 with you. I've given you 4 points, and we're going to form vectors RS and PQ. Now, we're going to use the head minus tail rule, and I'm going to abbreviate that as HTM rule. So as you can see, I've already drawn vector RS in a coordinate plane, where S is considered the head and R is considered the tail. So to create the vector RS, I'm going to take -1 and subtract off -4 to create the horizontal component. And then I will take 6 minus 2 to create the vertical component. And we end up with the component vector 3, 4. Now you can see that I've drawn vector PQ. And I'm going to go ahead and find the component form for PQ. So again, I'm going to use that head minus tail rule and take 5 minus 2 to find the horizontal component, and then 3 minus -1 to find the vertical component, and I end up with a vector 3, 4. Because vector RS and PQ have the same component form, they have the same magnitude and direction, therefore they are equal. The direction of a vector is the angle between the positive x-axis and the vector drawn in standard position measured in a counterclockwise direction. We will now work through example 2. So we're going to draw the vector v, which is -1, 5, in standard position, and we're going to find the magnitude and the direction. I'm going to encourage you to pause the video and draw your vector in standard position. So I've drawn my vector, and I've indicated what the direction is, and I've even indicated theta as my reference angle. And as we know from our previous unit, we can go ahead and use right triangle trig to find theta. So I'm going to make sure that I use a positive ratio to guarantee that I have a reference angle. So theta equals tangent inverse of 5/1. That gives me approximately 78.7 degrees. So my direction is simply going to be 180 degrees minus 78.7 degrees, and that will give me approximately 101.3 degrees. So now we're going to do an example that we're going to use addition, subtraction, and multiplication by a scalar to create new vectors. So example 3, we're going to consider vector u for -2, vector v, -2, 5, and we're going to find the following. We're going to multiply vector u by the scalar 4, vector v by the scalar 6, and then we're going to take 4 vector u plus 6 vector v, and then we're going to subtract the vectors. So I'm going to go ahead and find 4u. And all I'm going to do is take that scalar and multiply it by each component within the vector. And I have my new vector 16, -8. I'm going to encourage you to pause the video and try to find 6v. Okay, so vector 6v is simply again taking 6 and multiplying it by each component in vector v, and we will end up with the vector -12, 30. Now, if we go ahead and we add the vectors, I'm not going to redo the scalar multiplication, sorry about that, for 4u and 6v. I am simply just going to go ahead and add the horizontal components together, and then I will add the vertical components together. And I end up with vector 422. Again, I'm going to encourage you to pause the video and try to find 6 vector v minus 4 vector u. Okay, so now I'm going to go ahead and find that next vector, and I should end up with subtracting one horizontal component, the horizontal component for 4u from the horizontal component from 6v, and then subtracting the vertical component, excuse me, I made a mistake there. I'm going to subtract the vertical component from 4u from the vertical component from 6v. And there you go. Adding, subtracting, and multiplying by a scalar. Okay, so we've heard of unit circles, and we just finished our trig unit, but now we're going to work on unit vectors. So unit vectors are vectors with the same direction as a given vector, but have a magnitude of 1. So we're going to find a way to force the magnitude to be 1. As you know, I'm not a fan of reading things to you, but I am going to talk about this statement right here. Any vector can be represented by a linear combination or sum of the standard unit vector I, which is 1, 0, and j, 0, 1, which are unit vectors in the horizontal and vertical direction. So in example 1, we're going to draw vector v, 3, -4, in standard position and represent it as a linear combination of the unit vector I, j. I'm again going to encourage you to pause the video and draw the vector 3, -4. So you can see that I've drawn vector v, and now I'm going to go ahead and find the magnitude of vector v. Again, I will encourage you to pause the video to try yourself. You can see that I have found my magnitude of vector v to be 5 by using the formula. Now, I can write vector v as a component vector like this as a linear combination. So v equals, I'm going to take the horizontal component of 3 and divide it by the magnitude of v. So I have 3/5 I minus, now I've got the component form for, I'm going to take the vertical component, I apologize, of vector v and then divide it by the magnitude of v. And so you can see that now I've written it as a linear combination, and I can confirm that this new vector has a magnitude of 1. Go ahead and do that confirmation and confirm your magnitude is 1. You can see that I confirmed it. I did that over there in pink by finding the magnitude of the unit vector of v. And you can see my smiley face indicates that I'm very happy that we did that problem right. We are now going to move on to example 2. We're going to draw the vector S, which is 8I minus 15J, in standard position and find the unit vector with the same direction. I'm going to have you complete this all on your own, so please pause the video here in a moment, and then you will come back after you pause it and check with my answer. So that concludes our lesson for today. So if you can confirm that you have your answer right. I will be available for questions. I will send you out times that I will be available for you to communicate with me, any questions that you have, and you will have an assignment through Pearson My Math Lab. I've chosen to do this so that you can get instant feedback on whether your answers are correct or not. There won't be a limit on tries, and it will be a grade on effort versus accuracy. I'm so happy my dog Izzy did not start snoring until the very last few minutes of this video. So I'm sure if you listen closely, you will hear her sound asleep, bored from vectors. I hope you guys have a great day.